Hello, and welcome to Physics Required Practical 7, in which you are going to be investigating the effect of varying the force on the acceleration of an object of constant mass and the effect of varying the mass of an object on the acceleration produced by a constant force. Let's have a look at the equipment you're going to be using.
So here's your equipment list. You can see we're going to be using a trolley, a meter ruler. We're not going to use pencil or chalk, we're actually going to use whiteboard markers, a bench pulley, string, the string will be 1 metre long, a small stack of masses, a stopwatch. We probably won't need the blue tack. So this is how we're going to set the equipment up. Firstly, you're going to attach the bench pulley onto the end of the bench, and you're going to tie your piece of string onto the end of your trolley. That piece of string will go over the bench pulley and down towards the floor, and on the other end of the string you can see we've attached the small stack of masses. These are the 10-gram masses. You'll also notice that when the trolley is pushed up against the bench pulley, the small stack of masses is just touching the ground. So this is how you should be aiming to be set up. When the trolley is touching the pulley, the small stack of 10-gram masses at the other end of the string should be just touching the ground. You'll also notice that I have measured using a meter ruler from where the trolley touches the bench pulley, 100 centimetres, and I have marked 20 centimetre intervals using a whiteboard pen on the desk. We've also got our stop clock, of course. Once you've got the equipment set up, the first thing that we're going to investigate is how varying the force affects the acceleration of the trolley, which will be at a constant mass. Your results table will look something like this. So you can see along the top we have 1 Newton of force, and then as we move through the experiment we are gradually reducing the force that will be pulling the trolley along or accelerating the trolley. On the left hand side we've got the distance travelled in centimetres, so you remember I've marked out those segments on the desk with the whiteboard pen. This results table goes up to 100 centimetres, but you'll find when you set your experiment up you'll actually be only able to go back to 80 centimetres. You'll then see that in these boxes we are going to record the times, so how long it takes the trolley to travel 20 centimetres, 40, 60 and 80 centimetres. We'll then repeat the experiment as we reduce the force exerted on the trolley. So initially the masses that you've got on the far end of the string, you need to make sure that you have 10 of those. That will give you a mass of 100 grams, which exerts a downward force of 1 Newton. Once that is set up, we're then going to take the trolley back to the 80 centimetres. We're going to let go of the trolley and we're going to time how long it takes to travel each segment. So you're going to pull the trolley back to the 80 centimetre line, you're going to hold it steady and you're going to prepare the stop clocks. So you've got to start the stop clock the moment you let go of the trolley, then things get a bit hectic, so we're going to watch in slow-mo, because you have to record a time as the trolley passes each of the markers you've got on the desk. So you'd have to record a time now, record a time now, now and now. So for just one single journey of the trolley you will record 4 different times as it passes marker 1, marker 2, marker 3 and then the end of the journey. This is why you will need multiple stop clocks and multiple people recording times. You'll also be advised to use the lap timers, so 4 different times for each journey that the trolley makes. So once you've got your results, they should look something like this. You'll see that as the trolley accelerated we got a time of 0.46 seconds, 0.69, 0.88 and 1.04 seconds, so a time for each interval. You'll see that all this is taking place in less than a second, so you've got to be super quick when you are doing your timings. While you're doing the experiment, I'd also like you to have a think about the accuracy of your results and what the sources of error might be in this experiment. Once you've got your set of results using 1 Newton of downward force, you're going to remove 2 of the 10 gram masses, leaving you 80 grams, which will exert 0.8 newtons of downward force, and you're going to repeat the experiment. Then you're going to do the same again for 0.6 newtons, 0.4 newtons and 0.2 newtons of force.
Once you've completed the first part of your investigation into how varying the force affects the acceleration of an object of constant mass, you're going to move on to the second part, where you investigate how changing the mass of an object affects the acceleration when a constant force is exerted.
This time, what I suggest is you leave the small stack of masses attached to the far end of the string and leave it with 20 grams, so exerting a force of 0.2 newtons.
Then you are going to place the larger masses onto the trolley to increase the mass of the trolley. I would start with 200 grams. Once you've placed the masses onto the trolley, you're going to ready your stopwatch, just like before. You are going to take the trolley back to the 80 centimetre line, just like before. And then you're going to make sure that you start the stopwatch at the exact moment when you let go of the trolley.
And back to super slow-mo, so I can remind you that you have to record a time as the trolley passes each of the markers. So we start the stopwatch, then we record a time at 20 centimetres, then at 40 centimetres, 60 centimetres, and finally 80 centimetres. And you need to make sure that the masses don't hit your arm.
So then your results should look something like this. I've got 200 grams on the car, and then my split times for each interval: 0.66 seconds, 1.01 seconds, 1.31, 1.57 seconds. We then repeat the experiment, adding more mass onto the trolley.
So you add a further 200 grams, meaning the total mass that you've added to the trolley is now 400 grams. And once again, you take the trolley back to the 80 centimetre line. You ready your stop clock for your next set of results.
You'll then repeat that experiment up to 1 kilogram or 1,000 grams of mass on the trolley.
Once you've finished your investigation, I would like you to consider 3 things. Firstly, whether or not your results demonstrate Newton's second law, A equals F over m, or acceleration is equal to force divided by mass. I would like you to consider what the major source of error might be in this investigation. And finally, I'd like you to consider how you could improve the method to improve the accuracy of your results.